go to moles. So we'll take our 3.6 grams of water and we're going to divide by its molar mass of 18 grams per mole. Okay, we're going to do the same thing for zinc sulfate, which there's 4.6 grams of it, and we're going to divide by its molar mass, which is 161.44, or something like that. Pretty close. Okay, so we find that there are 0.1998 moles of water, and we find that there are 0.02849 moles of the zinc sulfate, ZnSO4. Does that sit okay so far? Now you know what to do. So divide by the smallest. Yep. Yep, so we're going to divide each of them will be divided by this value. 8 divided by itself is going to give us a value of 1. The 1998 divided by the 0.028 will give us right around 7. This will be 7.01 with some rounding liberties. And so you have a 1:7 ratio, which means that x must be equal to 7. Yep. Yep. X equals 7. So it's a heptahydrate. How about that? A little bit. Here, give us some work room. Okay. So the mass of the anhydrate. Right, the mass of the anhydrate should be 1 minus the 0.185. Right? So we take 1 minus our 0.185, and we get this to be like what? 0.815. All right, so this is 0.815 grams of the anhydrous, MCl2. We don't know what M is. We can even write that down if we want to label it. This is MCl2. All right, so we have that. The second thing we're going to want to do is we want to determine the moles that are water, and then that will allow us to determine the moles of the anhydrate. What? Hang on, so let's take care of the moles of water first. All right, so first we know that we have 0.185 grams of water, and we're going to divide by its molar mass. Now, if you're not sure with the direction in which to take these numbers, remember that we use unit cancellation. We want to get out of grams of water and into moles of it. So that means I can easily multiply by 18. It's going to be around 18 grams for every 1 mole of H2O. Right? The grams cancel, and we're left in moles. Helps me remember what I need to do. Or if you remember that you just need to divide by the molar mass, then divide by the molar mass. Use Mole Island to help you out. So you should find that this is 0.010278. Oops, 10278. I rounded it there. And this would be moles of water. Okay, so if we know the number of moles of water that were removed from this hydrate, how do we use this to determine the moles of the anhydrous that is attached to it? What can we use this moles of water, how can we use this moles of water to actually determine the moles of the anhydrate? This is the same reasoning that we used in order to determine problem 1 in your post-lab questions, where we had the inert material. We said we could use the formula of the hydrate because the formula tells us the ratio of things, doesn't it? It tells us that for every, how many moles of water? 2 moles of water, there is 1 mole of the anhydrate. or 1 mole of the hydrate to begin with. So we can use that information. So if we want to know like what is the number of moles of anhydrate, then we can simply take our 0.010278. This is moles of water. Right? We can drop that over 1. We can multiply by the ratio from the formula, that there are 2 moles of water to every 1 mole of anhydrate. So 2 moles of water on the bottom to 1 mole of the MCl2 on top. And it tells me that I have 0.005 139 moles of the MCl2. Okay, so there's a couple of key pieces of information that we've gotten in the second part. One, now we have the number of moles of water, which is great. And from that information, we now know the number of moles of the anhydrous salt. Okay, we needed that. And we use the moles of water to go back to the formula to determine the moles that is represented by the mass that is dry salt and how many moles that it consists of at that mass. All right, I'm going to wipe this off. Is that okay? Okay, I'm going to wipe this guy away. Gone. All right, well, we're going to take. We know that if we subtract these two, we said that the mass of the anhydrous salt was 0.815 grams. All right, and we know if we take this number, we said this equal to a certain molar mass that we don't know, multiplied by the number of moles of that anhydrous salt. So 0.05139 moles of MCl2. There we go. If we solve for x, we're solving for the molar mass of the anhydrous salt. Right? I mean, if we know the number of moles that should be present in our sample, right? We know it's 0.005139. That should be the number of moles of the dry compound that we have. And we know its mass after drying it, then the unknown is the molar mass. Because if we multiply the number of moles by the molar mass, we should get its mass in grams. Does that sit okay? All right. So if we do the math, we find that x is equal to, what do I write down here? 158.595. That's grams per mole and that's the molar mass of the anhydrate. That's the molar mass of MCl2. Whatever M is, it helps make up this 158.595 grams per mole. Okay, so this is critical because now, what's the last thing we need to do in order to find out the molar mass of M? Yeah, Chris.
There's 2 chlorides, so you take the mass of chloride, multiply it by 2, and then you subtract that from that.
Correct, absolutely correct. So we're going to subtract from this 2 times the molar mass of chlorine, which is 35.5.
Yes.
Okay. Right, which is like 71. Okay, so we subtract 71 from this, and I'm going to put my answer over here. That tells me that the molar mass of M, should be equal to 87.6 grams per mole. So now we look to the periodic table. We try to look for something that is 87.6 grams per mole. And strontium all day long. Yep, that's fine. Yep. This is a great problem. It's a classic problem working with hydrates, and using really applying the ratio from the formula of the hydrate to determine an unknown element in the compound. I felt it was a good one to add to our problem set.